So let's talk about the second example in this video. The second example to illustrate the coase theorem. Suppose there is a steel industry and it produces steel but also produces some pollution into the water. And there is a downstream result which is affected by the polluted river water. So we want to know what is the optimal level of the production of steel, because it depends on it affects the level of pollution, right? So who has the right to use the river? Does this matter if we want to find? Does this matter to the optimal level of production? That's my question. So from the perspective of coase theorem, it would not matter who has the right to use the river. If the steel industry and the resort, they can negotiate with each other and they don't need to pay any transaction costs from this negotiation, then the optimal level of production would be exactly the same, whether the resort has the right to use the river or the steel industry has the right to use the river. So first, if a steel factory has the right to use the river, what is the optimal level they are willing to produce? It would be QM, because it is decided by the intersection of marginal private costs curve and our marginal benefits curve. In this graph, the marginal benefits is the price curve. So the market equilibrium quantity is 8. If the steel factory has the right to use the river, they can pollute as much as they can, and they don't really care about the pollution because it would not hurt their welfare, right? So the optimal level of pollution for them would be QM equal to 8. However, from resort's perspective, the optimal level of pollution is Q star 5, because they need to take the damage, the pollution, the water pollution into consideration. So the social marginal cost curve, the intersection of social marginal cost curve and the marginal benefit curve is O, and the corresponding production is 5, is Q star. So in our first case, the steel company has the right to use the river, and they are willing to produce 8 units of steel. But the result wants the factory to produce only 5 units of steel. But they can negotiate each other, right? If the result offers a payment C plus D, which is pretty clear on this graph, C is the blue area, D is orange area. The result says that, I can offer you C plus D. Can you just produce 5 units of production, 5 units of steel? So do you think the steel company would agree or not? So if the steel company refused the option, refused the C plus D payment, that means it will continue to produce at Qm, which is 8 units of steel. Then the company's producer surplus, the company's benefit would be the area below the price curve but above the marginal cost curve would be A plus B plus C, right? ABC. And if the steel company accept the payment, then the producer surplus would be the area A, B, and the payment C, D. Why I say that? Why I say this? If the steel company accepts the payment, that means the steel company agrees to produce at Q star amount. So at the Q star, its producer surplus would be below the price but above the marginal private costs, right? Should be A plus B. But at the same time, it receives a payment from the result, which is equal to C plus D. So the total amount of money it has is A, B, C, D, which is greater than the producer surplus ABC when it produced at QM level, right? So from the steel firm's perspective, it is better off by D if they accept the payment. We call this payment the willingness to pay to avoid the pollution. And the willingness to pay is defined as the maximum amount to pay to avoid the pollution. Pay to avoid the pollution. To avoid, avoid the pollution. So if it's not the case, if the result has the right to unpollute the water, then the factory's marginal cost curve is the marginal social cost curve, because the steel company does not have the right to pollute the water because the river is not the company's property, right? So when our marginal cost curve is MSC, then the intersection of MC and MB would be 0. MSC and the marginal benefit curve, the intersection of those two lines would be 0, and the corresponding quantity would be Q star, which is exactly same the optimal level of pollution in this example when the company has the right. So at the social optimal quantity, the factory has to pay the result, the externality costs, because at this level, the costs of production is just the area below the MPC curve, and the producer's surplus is the area below the price but above the marginal social cost curve. So the area enclosed by the red lines, the rectangle area, is the externality costs that the result has to pay, that the steel company has to pay the result, this amount of money to ask for pollution. So we also call this amount of money the willingness to accept, to tolerate, the willingness to accept, to tolerate the pollution. It is defined as the minimum amount that willing to accept that result, SORT, is willing to accept pollution. So that is another illustration of the coase theorem. It does not matter who has the right of the unpolluted water. Even though the steel company has the right to the river, it can pollute as much as it wants, but the resort can negotiate with the company, and they can the society would achieve the social optimal level because of the negotiation. If the resort has the right, then obviously they can achieve the social optimal level, Q star. So this is the second illustration of the second example to illustrate the coase theorem. Similar to the first one, it does not matter who has the right or who has to pay the damage cost. Only if they can negotiate with each other, only if there is no transaction costs, only if the parties can be easily identified, then the social optimal level would always be achieved finally. So here is the reference for today's video. See you next time.